Focusing in this lecture is mobile TCP. So the mobile TCP has the same goals as that of ITCP and snooping TCP. That is to prevent the sender window from shrinking if bit errors or disconnections, but not congestion, was the cause of the current problems. MTCP aims to improve the overall throughput and to lower the delay. It aims to lower the delay. It aims to maintain the end-to-end semantics of TCP and tries to provide a more efficient handover. It also splits the TCP connection into two parts as ITCP does. An unmodified TCP is used on the standard standard host to supervisory host. So here the supervisory host will be present in the foreign agent. Okay, here we call that which controls which monitors the connection as a supervisory host. Okay, while an optimized TCP is used between SH and MH connection. SH is supervisory host and MH is mobile host. The supervisory host is responsible for exchanging data between both parts, similar to the proxy in ITCP. It is a proxy in the sense in ITCP we have the access point. So access point acts as a proxy. Similarly here the supervisory host acts as the proxy. The MTP assumes, the mobile TCP assumes a relatively low bit error rate on the wireless link. So this whole protocol is designed based on this assumption that there is a low bit error rate. Okay? So because of that, it does not perform catching or retransmission of data. Like how catching or retransmission of data is done in snooping TCP, that won't happen in case of mobile TCP. So the supervisory host, it monitors all the packets that were sent to the MH mobile host, and also it monitors all the acknowledgements that are returned from the MH. Okay. So this is for the communication from the correspondent host to mobile host. For all the communication from the correspondent host to mobile host, it monitors all the packet transmissions from correspondent host to mobile host, and also it monitors all acknowledgements from the mobile host on the return path. If the supervisory host does not receive an acknowledgement for some time, so say there is no acknowledgement coming from the mobile host for some times, then it will assume that the mobile host is disconnected. Then it will assume that the mobile host is disconnected. It will then choke the sender by setting the sender's window size to 0. This it will stop the sender by setting the sender's window size to 0. See, setting the window size to 0, that will force the sender to go into a persistent mode. That is, the state of the sender will not change as long as the receiver is disconnected. The state of the sender will not change as long as the receiver is disconnected. Okay. So now the sender will not try to retransmit the data because its window size is set to 0. Now as soon as the supervisory host detects connectivity again, it will reopen the window of the sender to the old value. So when once again the connectivity is found, it will reopen the window for the sender with the same old value. The sender can now continue sending data at full speed, right? So this mechanism does not require changes to sender's TCP. Okay. So this is how this technique works. But MTCP needs something called as bandwidth manager to be implemented, because it is required for fair sharing over the wireless link. The wireless side uses an adapted TCP, that is an wireless TCP that can recover from the packet loss at a much faster rate. Okay. So this modified TCP does not use slow start. Okay, so MTCP needs a bandwidth manager to implement a fair sharing over the wireless link. The advantage of MTCP are that it maintains the TCP end-to-end semantics. Okay. If the MH is disconnected, it avoids useless retransmission, slow starts, or bringing or breaking connections. All these it won't do, but it will just shrink the sender's window size to 0. The disadvantage of uh, MTCP is as the SH does not access the proxy like how the access point does in indirect TCP. Packet loss on the wireless link due to bit error rate is propagated to the sender. And MTP assumes low bit error rate, which is not always a valid assumption. So as we already discussed, MTCP assumes low bit error rate, but that assumption may not be true always. Okay. So this is how the mobile TCP or MTCP works. Okay. So let us stop here. Fine. Thanks.